Hello friends, in this tutorial, not even a tutorial, this is just a demonstration of a program I made because I think it was a program that really needed something to be done. This one is the simplex algorithm. If you are a statistician or somehow mathematician, most of the mathematicians have done this. So if you fall under that category, then this program should really help you in figuring out some things. I think you've ever heard of something called simplex problem. So simplex problem is just, I don't know how to explain it, but I think I will demonstrate. I have an image here of what shows what it happens. So you see, we normally have these equations. No, I will not use this one for now. Let me bring this one to be bigger so that we can all see what happens. So if you are a mathematician or somehow know some other, or just maybe even an economist, you just dealing with a business, a company, you want to maximize their profit. So you see, we have something called a Z equation. This one is just an equation you want to, for instance, maximize or minimize its, I don't know how to say, but I think you already know that one. Then we have products. Maybe you are let me use an example. You are supplying cereals, maybe foodstuffs to a certain school. So these foodstuffs can be in many categories. They can be drinks, milk, maybe cereals, maybe beans, maybe peas. So you see, so the thing is, you have these products, and then you have the cost of transportation, the cost of maybe if you're producing them, cost of maybe storage. So you see, those ones are called constraints. So in our case, this equation is a constraint, this one is a constraint, this one is a constraint, then this one is the equation you are trying. So you are trying to optimize, for instance. So you are trying to optimize this equation, maybe to maximize. You are trying to maximize. Maybe this is a profit. You are looking for a way that you can make maximum profit by minimizing, obviously, the cost you'll be spending in these constraints. Maybe transport, storage. You are trying to solve that. So this is a picture I took from my lecturer in campus. It was Mr. Owama. So this is my lecturer in campus. He taught me this one, I think, in my second year. Yes, so this is the image. This one was a document that I printed a long time ago, so it's now in image form. So this one, I figured out that the name was here, so you would think that, okay, my name is Mwana, know that this is the name of my lecturer. So now X1 and X2 are products in our case. Maybe these ones are cereals and these ones are beans. Maybe even they are what? Just think of any product that you are supplying, not specifically products that I want. Maybe computers, laptops, phones. Maybe you are working for a company that produces those things, so you can just think of it in that case. So I don't want to talk about it. So this program is already on GitHub, so don't worry of how you are gonna get it. So I have a program that will solve this one. This is normally solved by drawing something called W's. Maybe I'm talking in a case that I was taught, maybe you are not taught that way. So you see, the previous equation, we had it here being less or equal to. Now we are introducing something called slack variables. So you see, we introduced something here. Obviously it was less or equal to. That means to make it equal to 600, there is a value that you should add it to make it that one. So we don't know the value yet. So you see, in all cases we added this new variable x3, x4, x5 because we are trying to make it equal to. So in my case, in the program, you will not be writing any of this. You will just be feeding in the equation just as it is, and the program will be adding this for you and solving it and drawing for you these tables. I think if you know how to draw these tables, then if you don't, I should not remind you in this case. In fact, I've taken much time just trying to show you how they work. So my program will be drawing these tables, but it will be showing in form of lists. X3s, all these value will be there. Solution, I do not just include this solution variable, but this table from here till here is there, and again all these other values are there. So I'll be using this equation in my case to demonstrate my program. So To get the program, just go to GitHub. Let me show you. It's github.com. Then in this case I'm logged in as me, but in that case you'll be logged in as you or not even as you. So just come and search Kimotai Rob, for instance. Then so you will find something like EKR simplex problem, or just search for simplex problem. Just think of what you can search for: simplex problem calculator. Try Rob. You see, I think they are really poor in this, but in this case it's here, so I don't think so. It's here. It's try Rob EKR simplex problem calculator. So you download it. It's made of Python, so you download it. So in this case, this is the code. You can clone it from here if you want to clone it, but this is the code. You can again decide to copy this code. Just select from line 1 here all the way to the bottom, then copy and add it to a file called simplex.py, or a Python file that you will make, or just clone again. Why don't you just start or fork it? Oh no, I think that is myself looking for marks for myself, but yeah, why don't you just do that? Again, you'll need to install NumPy. I think this is it. To install NumPy, just do this one. Install Python first if you don't have Python. Then you don't need to learn Python, just do this one. Learn how to install Python. What I want you to know is install Python, and then install pip. If you do this is just what I will not cover, but please just do this for me. Install Python and install pip. I will really appreciate you doing that. So let me hope you will find a way to do that. Google has almost everything, so you Google for this tutorial, again you'll Google for that. I know it's not hard for you. So install NumPy, because I will be dealing with something called arrays in Python. In most of these things I used arrays at some point, not a lot, just some point, like somewhere here. I think arrays are really working somewhere there. I should not be telling you about the Python program, how it works. That was really bad. So if you've done that, then we can now just go. In my case, I will not download it. I have it already because I'm the one who made the program. So obviously it's in my, I think it's in basics. Then I have it over EKR simplex problem. Yeah, I think if you clone it, then you'll get it. You'll be getting something like this one. Just open in terminal, then I want to bring this one over here and bring this image. The image was already defined, but okay, let me do it. What? This way, because I want you to be seeing these equations as I key them in over here. So to run the program, just run Python 3. Use Python 3 because I think Python, yes, I used Python 3 in this program. Python 2 will fail at some point, so you just use Python 3 and then simplex.py. Write Python 3 simplex.py. They are not in two different lines. It was just making them really smaller. So again, here I figure out I need to add a space. Yeah. So you see, it's asking me, it's EKR simplex calculator. So what type of problem do you want to solve? In this case, you see, it's a problem to maximize profit. So in that case, you want to minimize this. You want to minimize the cost for maybe storage, which are the constraints. What? Really hard constraints, yes. There. So maximize. So it's in this case, you see, even if you don't understand anything, just look at this symbol because I gave it for you here, and then compare with what you have over here. There should be three of them. In some case, you'll find where you have mixed, but in this case I just made two because the other one will be complex because it's kind of tricky in writing problem, but for this case let us use this one. If you need that one, I promise it's in the way. I'll be making that one because I think I need to rethink again and come up with that one. So in this case let us use maximization because we are trying to maximize profit. So let's key in 1. The problem type is 1. If you want help on how to use this one, and again some things I gave about, you could key in here 0, or if you are using minimization in this case where you have these ones to being greater or equal to, then you can key in 2 and start keying in the values just as it asks you, because the way the values are got is just the same. So let's see. 1 in our case, how many products do you have? You see, in our case we have product x1 and x2, which it could be, for instance, cereals and let's say beans or peas or anything. So we have 2 constraints, we have 2 products. How many constraints do you have? In this case we have constraint 1, 2 and 3. With this one is not a constraint, this one is just was giving us the limit points, you see. So we have how many constraints? We have 1, 2 and 3. So how many constraints do we have? 3. Enter the constraint 1 name. Let us say it was transport, another one was labor, for instance, and just assuming, let's say another one was power. I think if we can go through this one, they are somewhere up there, but let me just use these ones. Enter the value of x1 in z equation. You see, it just asks you exactly what is here. So enter the value of x1 in z equation. You have 1 and 2. So x1 is 50 in our case, 50, and then enter. Enter the value of x2 in z equation. It's 8. So 8 and 0, and then enter. Enter the value of x1 in transport. I said in our case this one is our transport, this one is our labor. You see, it's here, transport, labor, power. So I didn't give the full name, but I think we can understand. So x1 is 3 in our case. Yeah, I think 3, yes. And then we have being x2 being 2. You see, it's asking you x2 in transport. Then now equate x2 to equate trans to, because equating these two, it's 600, 600. Enter the value of x1 in labor. X1 in labor is 1, and then again x2 is 1, then equating it to 240. I think you can see over here, just follow. X1 is 1, that one is in power, then it's 2, then it's 300. Just hit enter. You see the tables are drawn for you. Let's see. In this case, the first tableau in this one, which the lecturer gave, was 32100, which 32100, and the last one is 601. You see, the thing is, getting this z, you have to subtract you just 0 minus the z equation minus these values. These one are those which you had used to in the z equation. You see, they were 50 and 80. So it's 0 minus 50, then you get the values for these ones. So these others are the select variable I told you about. They are the values that were not there. You see, I don't know, I'm just saying slack because I'm used to that, but I don't know the term that I should use. But it's the error, maybe not error again. They are the values that you should add it to make it 600. You see, it was less or equal to in our equation. You see, if you can see here, it's less or equal to, it's not exactly 600. So that is why we made this x3, x4, x5, because for the we had to make them for the 3. I think you already understand how the simplex works. So this one was the initial tableau, which in my case is the first tableau. You see here I said it's the first tableau. So this one is the formula here, but in my case the computer finds in the formula and then it does not tell me, then it comes find the pivot element. I did not show, but the computer knows. If I wanted to print it out the formula for each, I would have, but I figured out that that was not so important. What you needed was just to know these ones so that you can compare. In this case, this one has the lowest value, of which you expect the second column to be the pivot column. So in this one, it's this one, which is 2 1 2 negative 8. That one is the pivot column. Then the pivot row is obviously you divide this one by this one. You see, you use the pivot column, then you divide that one, then find that with the lowest value, then that is the you use to find the pivot element, which in our case is 2. Now I don't understand, is it this 2 or this 2? But I think, as you can see, it's this 2, because this one, the pivot element should always be meant to be 1. So you see, that one is what it was meant to be 1, the other has to be 0. So I figure out this one was the least. Yes, if this one should give 150, this one should give 300. I know this one is the least, of course, so that's why then should give 300, then it should give 150. So x5 is the pivot element and x2 is the pivot column. So this one, x5 is the pivot, yeah, that one. So you see, you have to replace x5 here with x2. So that is why we did, we took this x2 and replaced with the pivot row, the value. So the x5 here was it was initially x5, but now it's x2. So that is what it's done until you find that the last row does not have a 0. So that is just what it's always done. So figure out that you already know. So the thing will continue until you find, I think I have cut out some values, but yes, this is the simplex problem, it works this way. So thank you guys. Test if you have some bugs, then I'm going to fix this bug right now and show you. I think you already know how it works because I've not recorded the video. So until next time, goodbye. If you have any question, you can ask and I'll be glad to answer.